guys for spending out your Friday with us. We are honored to have you here. Okay, so first of all, this is a near and dear topic for me, not only just for me, but overall everybody. And one thing which comes in is like, hey, we did study data structures sometime, in the engineering domain, and what's really happening is that how the industry is shaping. So this whole talk is to make it towards more real world applications. Like there are algorithms. Yes, I know how to sort. There is a dot sort. I can sort it. Like, what the heck are we talking about in this? So this is what, as this whole talk is based on practical applications. Where can I use my algorithms to solve the real world problems? So that's where we're going to start. So I hope you enjoyed this session along with me. So we're going to start, and if you want to connect with me, please connect with me on the LinkedIn. It's right here on. You can get it connected. That'll be great. If you have any questions, you can ask me also. All right. Now let's talk about what would be the things if we would be discussing some of these things today. Maybe we discuss like half of it and see how we are progressing, and as Michael will decide like, hey, where we put the stand in the ground and for any questions afterwards. But the whole idea is to give an understanding of steps, then looking at algorithms by itself, like what are the structures and different types of algorithms for searching and sorting. Graph algorithm will spend more time on the graph today, and and look at some other algorithms later on. But I don't want to just stop there. I just want to give you like a real world example of an actual company using these algorithms. So that was the whole point is, instead of just saying, oh, this is some algorithm which is there in the ancient world in our textbooks, and then we're going to, how do I correlate with this? So that's what the whole question is, which we are going to talk about and discuss. So there are 7 steps for cracking the algorithms. So when we say steps, that means these are some of the paths. I suggest like going through, and if you want to brush up, like cracking the coding interview is a great book. Even if you don't go with that, that's fine. There are other books which are available, like we can talk about it in my longer session. But this is like one of the book I recommend you. Just 1 minute, if you want to go somewhere, that's the book you want to get. All right. So Einstein said that if I had an hour to solve a problem, I did spend 55 minutes thinking about the problem and 5 minutes thinking about the solutions. So this is what is also true with algorithms. So when we say algorithms, we want to first do few things when we work on it. What we do is we want to practice this on paper. So when we say practice on paper, what does it mean? Like, it means that, uh, when we using autocomplete features and other things, we are not really using our right brain activity. Just what are we doing? Like, we just go to the Google, we type in something, this is the algorithm I want, okay, cut paste, and we are able to do that. The pitfall is that like we actually don't use both the brains to really solve the problems on the paper first, and this is what hone in for us to really get that going. Another is like we're going to do some of them today in our session. We're going to do a lot of them, is do some mock challenges and see if you have a certain similar situations, how can you solve the similar kind of problem. Do you have any other way of solving this problem? That's what we're going to look at, and see how can we approach this problem from different angles. Believe me, when a problem is given to us, we can solve it the old fashioned way, like using mathematics, like plus addition subtraction, you can solve a problem. But the main thing is how efficiently we are able to solve a problem. So that's the key part which we need to understand and listen to the details. So that's where the empathy map comes in. I just want to hone in on the empathy map. Understanding the customer, I would spend more time understanding the customers, with understanding, hey, they said, hey, we just need to solve this problem for a given domain. But and that domain, let's pick a domain, dresses, like hey, I want to get the trending dresses which are coming in the industry. The new trend which is coming in, I want to see those dresses. So what kind of dresses are these? They are for males or for the females or for the kids? What season are we talking about? So those are the questions you're trying to ask, those questions to make it like frame those questions to make it like more interesting to understand the problem. So what happens whenever the problem is given, we are almost always around 30 to 40% is not even listed in that problem. So certain things you have to put in assumptions. I understand that, but it's always good to ask questions. And exactly, this is another problem which happens is like, whenever a problem is given to us, we just start with the positive case and with some small input instead of getting a realistic case. Even if that realistic case means that, hey, the input is what happens if the input is 10,000 in the input. Yeah, my program can take anything. What happens if it is a million? How am I going to solve this problem? So this is where we have to tie up the boundaries. Like, what is our boundary in terms of how many number of cells we are trying to portray and use. So another thing is, now comes the designing of an algorithm where we are optimizing that algorithm. Once the pseudocode is written, writing the beautiful code is easy, because now I just have to, take it from there and put it in, and after doing a whiteboarding of that problem, putting into code and make it work. So the main thing is like, first time when it runs, let's make it work. Second time, make it modularize. So this is another part which always comes in, like, have modules, or try to see if there are microservices or there are certain things which we can break to make into different pieces. Then once we do that, the part which always comes in is, how am I going to test this? This comes in like, when we're doing interviews or otherwise also, how am I going to test it? And we always test with the positive conditions, and we will talk about much more different types of conditions which we can do. But the main problem which always comes in is like, when we are working on a problem, we have a very small test to work with, and we think that our test is all working fine. So what do we need to do? We need to code line by line, and then be able to find the boundary conditions. So whenever something is given to me, this is the one question which I always ask: what is the input? What is the output? What's the input? What's the output? And then sanitize parts of code which looks odd, like, sanitize and scrutinize the code which looks odd, and find out some errors in those. This is, you're writing pseudocode, there's no real code you're writing so far, but that really helps you solve the problems. Now, how many times we are trying to solve something, and the first thing which we get is like, you have to write the first name, last name, email, and gender, and other ones. What do we do? The first thing we do is we put our name, then our pet name, then our spouse name, and then what do we do afterwards? So that's where, we should have a good test. So, so there are two tools which I suggest here, because, hey, I want to make it actionable now itself, even if you join the next session or not. But, what you can do is you can create your own schema. You can add your own schema. You can say, I can add another field. And then that field you can pick now. Oh, this field is a name, which is an avatar name now, which is this size. And now what I can do is I can preview my data. Now this data which I'm previewing is data which is fictitious data, which they have created. Now we have something to test with. So so are you guys able to hear? Just want to make sure. Okay, great.
We can hear you.
Okay, great. Thank you. So the main question here is, so what I'm trying to say is that you want an IP address, you want some real addresses to test with. Boom, one good way of testing it, that same data. Same thing is true with this one, like, generatedata.com. Now, generatedata.com, you can export in HTML format, table format, like all these data will be there in the table format, or any of the programming language, JavaScript or any other language you want to generate a code for that, it can generate a code and boom, it's ready for you to, start taking that code and start using it. So that's the key part. So you can create a JSON object, you can do other things, based on it. So one small thing, 5 minutes here with me, and you have a clear understanding of what are the different steps which we need to use to solve these problems. Yeah, that was the goal behind this steps for interview coding. So let's talk about algorithms. So when we say algorithms, it doesn't matter whether it's an algorithm or a part of a system. I always ask, what is the input? What is the output? What are the boundary conditions? What are the negative conditions for this? And which are the dependencies for this algorithms? And what is my upstream dependency? What is my downstream dependency? Once I know that, it makes it easier. Now, the part which we need to work on is it algorithm needs to be clear, unambiguous. When we are working on through the steps, it needs to say what it's trying to do. It should be well defined outputs. So when we say, oh, we need some output in JSON, not really. It's good to define the output first. API first development. Whenever we are doing API first development, we want to first focus on creating an ideal design for us. Where do you get the ideal design for? I'll just give you one simple part of this, which is schema.org. Go to schema.org, put your domain, put organization as a name, and you would be able to now be able to create a clear defined JSON schema, which is a perfect schema for you to use. Make sense? So that is where you want to design your application really well, and output should be clear and input should be clear, and it should be feasible. At the end of the day, we should be able to design the application. All right. So here the important part is schema.org. It should be feasible and language independent. I can write it in any language I want to write. Now, in terms of complexity, one of the thing which always comes in is how complex it is. There are two kinds of complexities are there. I think we studied in our books here, if I am having a for loop, if I'm going through all these numbers, it's n times is my runtime complexity. Is n square here. The higher the complexity, the more complex the problem which we are trying to solve. So that means when we are solving a problem, you have to look at complexity ranking in terms of when you're computing it. So there are two kinds of them. One is computation complexity, which is like a simple one, on square, or npm, doesn't matter what it is. So that's one way of looking at it, where you're trying to find out a balance between on log n, coming up with this. How can we do that? Even if there are multiple variables, there are techniques to do it. You can keep certain things in memory. We will talk in more detail in our sessions, but just to you may have n square or n to the power of n. You can reduce it down. That's what I'm trying to portray here. Now that said, data structure wise, whenever we are using an array, we have to understand when we are using an array is very good, but if I need to do an insertion to an array, it still takes, it could take more time to insert the data. So depending upon the algorithm what we want to use, we may have to pick and choose between these. Do we want to use a hash table? Hash table is really good for insertion. I can insert the data without any problem. Q is the same thing. O of n means it's going to be really fast for me to insert or delete the data into a queue. Search would be costly. So that's where the hash table we use for searching, where we are keeping a name value pair to really solve that problem. So we'll talk about some of these aspects of it, in our talk. But the main thing here is when we talk about algorithms, you can say, oh, simple algorithm can be linear search. I want to search for J. It's an easy way of searching. You start from here and you go till J. Probably not that efficient, but that's one way. If we are not ordered, that's one way of doing that. But if I have an order in place, I can do a search which is the binary search. So that is one good way to do a search. I would put it this way. So whenever we are searching an algorithm, binary search is a good way of divide and conquer and find out the number easily in this case. Okay. Now, sorting algorithms wise, the main ones I would suggest here is quick sort or merge sort. So if you see the merge sorts here, that is O n log n. So that's the merge sort. So we need to see, worst case, what is the worst case looks like for the time complexity? What's the worst case looks like for the space complexity? So if the space is a problem, we would also want to look at the space and try to solve that problem, differently. But if I go to bubble sort, it can become n square, which is not good. So you have to pick the balance between the two, and pick and choose what you want to do at any given time. Yeah. So that said, there are many algorithms. I would not go in detail today, and I will spend more time on this in the sessions. But the whole point is you're basically splitting each element into partitions, and then you are basically making sure that when you're doing a merge sort, you're putting the one which is the smallest on the left side, and then you're creating two way of creating it and using this one. So that's the way this one is done. All right. So let me just go and talk about one question, because this is a simple thing which we do. But let's talk about a question. Now the question here is that we have been given unsorted array, 10, 5, 6, 3, 20. And what we need to do, we need to create an output which is a waveform of an output. Waveform of an output. All right. So it can be. So I see that there are some. So Jeffrey, you have said something. I'll come back to you. Okay. So just give me a second. Just give me a second. We will come back to that one also. All right. So that said, one of the question which is here is that what's the sort looks like if I need to create a wave, what do I need to do that? Any thoughts on how can we do this? So for this one, we have been given an output and we have to create some kind of an array which is the waveform of an array. What can we do for this? Any thoughts? Okay, that's good, Jeff. So that's good. yeah. So okay, so that's good. Yeah. So Jeff, I think sorting is more of an abstract for us, because if I'm using Java, most of the heavy lifting is done by somebody else. But where are we using sorting is more important. Yes. So that's actually a good point you have said. So what can we do here? Any thoughts on this? Guys, I just want to spend 1 minute on it and then move on to the next part of this solution. So what are we saying is we have numbers here, 10, 5, and all these numbers are there. You have to create a wave. Just ocean wave is there. So you want to create an ocean wave out of it. All right. So let me see what can we do here. Okay. So first thing we can do is we can just sort this. Yeah. So sort into two groups. Maybe one use the odd indexes and the other use the even indexes. So that could be one way of putting it, but it's only one. One element is there, and yes, that you are close. You are very, very close. So what we are saying is a simple solution is basically we do the sorting. Now everything is sorted. So if I have an input, it's been sorted now. After the sorting, it becomes like this. And what we do is we just swap the adjacent elements. That's it. If I just swap these two elements, it's an easy solution. I was struggling with this, when I was trying to look at from the perspective of how do I create a wave pattern? And there are many other ways to do that, to the tangent, and you can make it complex also. But try to find a simple solution. So that's where, the swapping makes it a simple solution. So the whole part here was, the problem become easy when we are able to sort it, and just for the adjacent array, we are just swapping them. So this is with an assumption that there are no duplicates. We are trying to do a simple question right now. All right. Granularity of the curve will determine the best algorithm. Yes, exactly. That's true, Jonathan. So this is also depends upon if there are duplicates, then we have to think about, oh, if there are duplicates, then it's not adjacent, but any of the value which is different. So if the 3 repeats, then we don't want to do that. We want to keep it in the same curve. Make sense? So that's a good point. So yeah. So requirements allows equals. Yeah. The comparison. Yeah. Yeah. So don't think you even need to sort the initial list. Yeah. Well, it depends, Craig. Like, if we have a list, like, which is there, like, we can be greedy also, and I'll talk about greedy algorithms, like where we can make it, like, even if you don't sort it, if you do certain things, to make that possible. Yeah, all great questions. Now let's talk about graph. Now graph is basically a node. You have a node. Between the two nodes there is an edge which is there. That's pretty much what edge and lines are there in there. And from the graph perspective, there can be a unidirected graph, unidirected unweighted graph can be there, or weighted graph can be there. So first question which I have is, where do we use these kind of graph? Like, where do you think we would use this kind of graph? Where do you think we use this kind of graph? Optimization, social connections, yeah, social connection, mapping relationships, mapped, yeah, that's another thing which we can use it for. Now, why do we use here product recommendations? Good, yeah, that's awesome. So why do we use adjacent metrics? So we use adjacent metrics basically, which helps us determine, between 1 and 0, there is one element here. Yeah. You can either use adjacent matrix, or you can use, an adjacency list. So depending upon, the number of element which is there. If you have a graph where you have all the elements are connected to each other, it's better to use adjacency matrix while you're doing going through the work. But if it is a sparse graph, in that case, it's good to use adjacent and adjacency list in that case, right? Now, that said, the question which is there is like, where all we can use this, neural networks, we can use it. So who's my friend? Who's the friend of 0? And how many links does the 5 comes in? Like, who has most friends? The person who has more friends get more weightage. Yeah. Is there a commonality between the two? Is there any isolation? There is no friend within the solution. So this is like something which is used in LinkedIn. And we all use this kind of network to really find that thing out. Yeah. Or you can have a disjoint sets. You can have a 2 disjoint sets which are working with each other, like, and they are 2 separate graphs for us. Now, another thing which can be there is directed graph. Now, give me an example of a directed graph. What do you think an example of a directed graph is? Google Map can be a directed. Google Map is actually directed graph which has weights also in it. Because Google Map, if you think about it, it has distance also associated with it. But you're right, like, but if, let's say, deliver routing is another one, deliver routing also is another one, which could be a directed graph. Yes, that's true. That's true. But this one does not have a weight also. It does not have a weight for now, at least in this case. Git commit history is a directed graph. Yes, business processes you can have, workflows you can have in these ones. So the main use here is, like, let's say, who is gifting who, that, you can think about this, like, who 2 has got a gift from 3. and 5 has got a gift from 4, you know. So you can have a directed graph, or 4 has got itself, they give a gift for itself. So how would Amazon use this? Think from that perspective. Amazon would use it differently. Amazon would use it is like, you know, hey, how many people are self buying or they are buying for others? Now they can suggest that their birthday is coming, you need to purchase more stuff. Make sense? Yeah. Another thing you can add to this is like, you know, a lot of people have said that here, you know, deliver routing and other ones. So one of them is a, you know, transportation network, you know. So from station 0 to station 4, what is the least amount of time it takes to do it? If you see this here, if somebody wants to say 0, 2, and 4, this is the least amount of hops, but this is taking the most amount of time. Yeah. But if I go this route, 6 plus 3, you know, this is taking the least amount of time. So this is where we are using, you know, we are using this this graph to really find that solution. Make sense? Now, another thing we can have is directed acyclic graph. So when I say directed acyclic graph, that like in this one, you know, it can go from, it can be going anywhere. But a directed acyclic graph is an acyclic graph, which is like, you know, always in one direction it's going. Yeah. So where all we can use a directed acyclic graph? If somebody asks a question like, you know, where do you have you seen using this graph? Build systems, yeah, you can use it in the build systems, yeah. Anything else you can use this for? So if you think about scheduler, like, you know, anybody who's doing a scheduling, yeah, if you're doing a resilient architecture, I'll talk about an example for that. If you are designing a compiler, you know, you're building a compiler, you want to perform certain operations and it failed at certain point, and then you want to process till 3. You don't want to reprocess, start from 0 and go till 3. Yeah, that's where it's useful. For example, I have a, in order to, for someone to take a class for 3, class 3, they must take 1 and 2, and they must have also taken 0 as one of the classes. So that's one way of like putting it through this example. Now, one example for this is Spark. You know, I know that we are not talking about Spark here, but if you see in this example, what we are doing is we are reading a file, we are flat mapping that file, and then printing the word comma separated word counts. So how many words are there, comma separated words are there in this one. So this is what we are trying to do. We are doing the map and reduce and collect at the end. So what could happen when we are doing reading a text file, we flat map it, we are doing a map, at map it failed. What happened in that case? That's exactly what the resilient distributed data set, RDD, comes in. So where are we using this algorithm? We are using this algorithm to make it immutable, recomputable. So I can recompute the same thing. It's fault tolerant. So that means resilient architecture. It's very much used there, and reusable. So once you get the data set, you can reuse that same data set again and again. So going through different iterations, like if I'm processing a record, like I'm going through different iteration 1, iteration 2, iteration 3, I'm going through this map and filter, and then we are reducing at the end. So does that mean I can reuse that same one? Yes, I can reuse that same one. But the beauty about this map is that what happens if C fails? I just have to start from B and recompute C, because B is still there. So that's the beauty about this. So this makes us like more resilient architecture when we are building it. So in this case, the recovery is much faster. That's the big advantage we have in this one. Another one is a tree graph. Like when you have a graph which is still a graph, but it's a tree graph is there, like where you have adjacent matrices are there. Within this you can have in this case. So that's another place where we can use this. Another one is like, cyclic, cyclic graph. So why the cyclic graph is not good? Why do we need to find the cycles in any project? Like, in any system, why is it good to know the infinite loop, avoid the loops? Yes. And deadlock, there is a possibility of a deadlock also. Like if you think about networking, like if it's a networking example, when I'm going from one node to another node, I will that packet is going to come back to my node, keep on coming back to my same node. Same problem happens like, when we are trading a currency. Like this is if I add two more nodes here, then I can explain you this in more detail. So what happens is that like when I'm trading a currency, now that trading currency means like, from US, I'm converting to Canadian currency, then I'm converting to another currency, then another currency. And at the end, they could be a negative currency. So there are people who actually play with the system and then, the amount of money you put in after all those conversion rates, you gain money at the end. So you want to avoid like, circular dependencies in this one. Yeah. Yes, exactly. So Jonathan, you have a good point. Like currency arbitrage is pretty sleek problem to solve. These are all real problems I'm discussing right now here. Another problem is a complete graph. Like, you have been given a complete graph. Who in the world will do a complete graph to begin with? Why we use this kind of graph? Anyone? Why do you use this? Why do you think this is really useful? Resiliency, high availability for a cluster. So Bill, so this one is actually what we are doing is this is that old telephone system. Yeah, you can say that. Yeah, is they all connecting, driving maps. Yeah. So this one is worst case. We are trying to test the worst case of your algorithm. When you are stress testing it, you want to do adjacent mapping for all these nodes. So this is the worst case scenario. This is the worst case scenario. What would be the worst case response time before your algorithms can bring back? Now, blink of an eye, like, the algorithms, anything which we run, it should be in materialized views. It should be all ready for us to go. But how much the algorithm really takes to complete it? Does it take 5 seconds or does it take 2 seconds? So that's the question which we need to ask. That's where we are using this one for. Now another one is priority queue. So when we say priority queue, you're putting in a queue and then you're dequeuing it. So where do you use this? Like, have you seen anyone using this algorithm? Priority queues. IO scheduler, yeah. Input queuing, yeah. Yeah, we are doing a queuing, messaging we are doing. But tell me a real example. Like example means these are technology stacks which we are using here. Yep. But tell me a domain. Ambulance. Okay. Yeah. Ambulance gets a much bigger priority. Yeah, that's true. So yeah, so you can think of this as like, when certain things are coming to you, so, prime shipping. Yeah. So prime shipping, you're getting a priority queue and you have to dequeue from that when it's coming in. What happens when somebody's going to a restaurant? We go to a queue, and and then if you are a priority member, you are being given a priority, but you're still residing there. Now same thing is true with like air traffic control, like the ATC. When the ATC is working on all the planes, what they do is you have a scheduled aircraft, like which is like 6 minutes, 3 to 6 minutes, you have to keep on rotating them. Yeah. So so you want to make sure that the plane who has more fuel can stay there for 15 minutes or 30 minutes. So that's where they all do all those calculation, and then they really use it in create a holding pattern. Like you see the plane is always there rotating, That's what they're doing, because this is a holding pattern for some of these things. Now another one is weighted directed weighted graph, like we talked about this. Yes, we transportation network, we use this one very easily we use it. Priority queue, like why not have one queue for each priority? Yeah. So Jeff, it depends upon, like, so Jeff has a question, like, why not have one queue for each priority? You could have it. It depends upon, like, how you want to design your system. There's no real answer, like, oh, this is the only way to solve it. But I'm just discussing, like, some of the things which would cause us problems. So for example, let me go back to one example here, which might give you a good understanding. Yeah, so this, okay, I'll come back to it, sorry. So I'll try to find out an answer. I'll get back to you on this one. Okay, just give me a second. Yeah. So what's happening is, so there are two main algorithms which are used. There are two main algorithms which are used for all the places, like, breadth first, depth first, and breadth first. These are the two main algorithms which are there. Depth first means you always goes down, and then you come back up, and then you go to the next one, and then from here retract back up, then come back, and then retract back up all the way up, then go down from here. So that's the way the depth first search work. Yeah. And so this is the way the depth first search work. And then the breadth first is working the similar, like you go here and always doing the breadth first. You're going to cover these two and then go back and then do these ones. Now it depends upon, like, what's the use case. Depending upon the use case, you're going to pick, like, different ways of dealing with it. Yeah. So whenever we want to find a deadlock, whenever there is a deadlock, you're going to use depth first search in that case. So if you want to detecting cycles, I talked about the cycles, like we have to detect the cycles. So easier to detect the cycles using depth first search. That's like one way of putting it in this one. Make sense? Now another one, like, which I actually stopped here, and there was a question on the queue. Another ones, one of the issue which we always face is the bridge. There is always a bridge between 3 and 4. What does that mean? Can anybody tell me what does that mean? Whenever I have a bridge, is that a good thing, or is that a bottleneck? If I'm talking about networking, it's a bottleneck. Exactly. So what we do is that we find out wherever there is a bridge like this, find out how many bridges are there, and try to, then this is very much used in networking, and to find out the bridge pattern and then solve that bridge pattern. So this is very, very important in using networking. Now we are all familiar with this single source shortest path, like, Google. We can use Google to really solve that problem. This is a very clear problem, like, which is, there are algorithm which does that. Bellman-Ford is there, BFS is there. There are Dijkstra patterns. We'll talk about them later on, like when we get more time. But you can have weighted and unweighted both. Yeah. So but how do we do it? Like, if I need to see it in action, like, how does it really look like? So let me just show you this one. So this is the graph which I created. These are all my addresses. Yeah. I just say, hey, I'm a salesperson, I'm a delivery person, I need to go to A, B, C, D. I need to go to these main restaurants, and these are the places I need to go to. What's my shortest route which I need to do? I set my goal. Oh, I'm starting at 2 p.m. I'm starting this at 2 p.m. and I've said it's a plan my route. So what it's doing is now looking at it and looking at the best path for me to follow to really solve that problem. So that's what it's trying to do at this time, in this case. So and it actually gave me the same result, which is good in the in this case. So that's like another way of putting it, like, one way of for you to understand that, hey, this is a real problem which we all face, and how do we solve that problem is the key part. Yeah. And I just showed you one example of it. I'm going to show you many examples, like, few more examples in next 5 minutes to get your interest up in this one. So what it means when I say algorithm, everything is algorithm. Yeah. Mathematics, everything is mathematics. But then when we go to machine learning and deep learning, what we are doing is that we are looking at the past data, and then we are predicting what the future should look like. Yeah. And there are a lot of algorithm which fits into this. And in the next few slides, I'm going to go through an actual live site where we're going to go through and see, how they solve this problem. Yeah. So does that make sense? So what we're going to do is that we're going to go to Stitch. Stitch Fix is a style website. Anybody here using it? I doubt it, but it's a very inspired site. Like, it gives like different ideas, not only for girls, but for men's and kids and everyone. It gives different ideas, but it looks like a very simple idea, simple shop where I can just look at different outfits, things like that. Yeah. So anyone who has done similar kind of work, like, you're looking at a site and then working on it. Yeah. So this one is just one way of looking at it. Now you can talk about men's, like, hey, men's, I can change to men's, like, that's fine. So you can have active wear, or you can have casual wear, cozy wear, and weekend, like, how should I wear in the weekend? Now this is more from designer wear, is more from the woman perspective, but men's also, like, you can give a quiz here, and it will actually subscribe, and it will know exactly, like, how you're using it. Like, you tell, like, bottom shirts, how it looks like. Do you wear tie? You don't wear tie, things like that. You give you some of your preferences. That's what you're trying to do here. Yeah. Exactly. So it gives a really good understanding, how they're using it. So let me go over this with you as a journey, with how they have gone through this whole journey. Yeah. So this is what we're going to look at here. So their business model is very clear. They want their customers to tell, hey, these are the things which we want. I want to get these things, and get those things to them, ship it to them. Hey, you will like this style, this something new style which is coming in. So what's really happening is, what they're trying to do is, they are trying to define the warehouses. Like, once the person comes in, they say, hey, on February 14th, which is coming soon, like, hey, I want this outfit to be there, and okay, wow, that's good. Rajiv, so that's good. So I'll tell you, all the clothes are good. Okay, good. That's awesome, man. This is good to know. So what that means, that, February 14th, after they know what February 14th is, now what they need to do is, they need to now write an algorithm to find out for the client which one is the nearest warehouse. So what did they do? They use the nearest, like, traveling salesman algorithm, and they weighted them, and then see that, whether that stuff is there or not, and then, be able to assign. Now they assign Texas in this case, because that was the closest one, and they're able to use this one. Yeah. Now they're using, intelligent machines. So when they say intelligent machines, they are trying to find out, you like these kind of things, but you never told about trousers, what kind of dress you want to wear. You don't know about this data. You have not given all the data to them. What they're doing is, they're coming up with an assumption based on the past data and producing this data. So that's where another one, where they are using, algorithm, randomizing the effect, and creating latent features for the customer, which is not even there. Now, one other feature which is interesting here is the medium size. What is medium size? Like, I go to a store, and actually I have to try out so many things to really find what my medium size looks like. But if you really see this, like, when I'm looking at a medium size, medium could be different for different people. You have to find out what that medium size looks like, because that can keep on changing also. That's one of the challenges which is there. Now, when I'm working on a Google site, what I'm doing, I need something to wear casual outdoor wedding. Yeah. Just by these 4 or 5 things, what they're trying to do is now they're ranking it based on, like, Texas, February 14th. Now they are going through each and every person. Now they're going through each and every person who can help them and trying to find out the feedback for them and then helping them out. Now humans are now working on their thing. They want something on their wedding for February 14th. They looked at that data. Once they look at the data, now they're finding out, oh, you know what, this data is there February 14th. These are the things which are there in these warehouses. Now I need to collect the data from them, identify the things. And after I identify the thing, I need to create one shipment out of it because they are there in different warehouses. And then basically ship it to her on February 14th. You know what I'm saying? So this is where, we are trying to keep them happy. Now where she's sending the request out, the delivery is being sent to them. She said, oh, I like 3 of them. Out of the 2 of them, I don't like. They return back, request more data. Now, based on that data, now I'm sending to the logistics and that data is coming in here. What it's doing is there is a warehouse is also there. You need to work on that warehouse to really make that happen. So I'm trying to define different problems. And same thing is true with different personas. You may have a persona which is just started working with you. You may have a persona which is buying a lot of things. You may have a persona which don't want to buy. They want to buy a latest trend which is coming on. And that is another thing which is there. Depending upon the demand, you are going from one state to another state. Yeah, you're going from one state, you are going in, and you're depending upon the demand which is coming in, you want to replenish the warehouse. See, put all of them in the replenishment model. This is the key part which is there. You want to replenish it and donate. Also, you have to donate because you have to keep on working with them to really solve that particular problem. Not only that, like, coronavirus is there, it's doing mutation. We all know the mutation which is going on. Same thing is true here also. They need to do mutation on the people what they like. Yeah. So that's what happens. Like, they want to get certain things. They want to find out their stars, what they like, how the people are liking it, and then producing the results based on it. And then based on that, now we have a data modeling here, which is basically working on top of it to really solve, now what we are doing is we are creating a data platform. We are running Lambda operation. Now this is where our analytics comes in. Now I'm running all my Lambdas here. Serverless operations I'm running here. Now it's all processing the data, having it ready. If something goes wrong, it's okay. I can refurbish that thing through resilient architecture. So my data analysis, we don't need to worry about that to really, solve that particular problem. Make sense? So this is the key part which I wanted to hone in today. I know that I could take, another, few hours, but I just wanted to stop at here. Just want to say, any questions so far? Did you like it? Get your input on it?
Yeah, I'm going to weigh in right away, both taking my moderator privilege, but also to fill some time for folks to either toggle on mics or type questions into the chat. But I really like this for a number of reasons. One of the perceptions that I've seen in our industry in engineering is that algorithms seem to be relegated to bad interviews. It's write this algorithm on a whiteboard and then come join us and write nothing but jQuery code or something like that, where you're never going to do any of this stuff in real life. And what I liked is you explained a lot of these concepts, you grounded them, and then you talked about how this is how people are using these skills in the real world and solving some really complex problems. And I think that context is really important. I want to thank you for putting that context in there.
Yep. Yep. Thank you. Yeah, I think the important part to remember is like when we are looking at different sparse systems. You have a warehouse system, you have a client system, you have a human computation which is happening here. What you need to make sure is that is that how the data is correlating with each other. That whole processing is currently happening through machines. Yeah,
Mhm.
but that machine need to be efficient enough to solve your problem, and that is where the algorithms comes in. You can solve the same problem, it can take 10 hours to solve it. You can solve the same problem which can take 100 milliseconds to solve it. And there are design patterns to really help us, like algorithms are there basically to help us, because like for example, Dijiksha, like that was from Google. But then Bellman Ford came along, and there are other algorithm which came along, 3D algorithm which came along to basically look at the same data differently. Now they are more efficient than using the older algorithms. So you, just like any other computer science fields, we have to see, we have to find out which one, what is really working in the industry, how we are solving that problem, like how we are tackling that problem.
Awesome, wonderful stuff. So, what I want to just kind of say in closing, and I'm gonna let's see. Well, if you want to go ahead and stop sharing, Rohit, I want to show one thing to the folks
Sure.
before we wrap up,
Okay.
and that is this. I mean, so obviously, um, a lot of what we think of when we think of algorithms, we think of like the foundational ones, the stuff that we learn in CS, the stuff that shows up on whiteboards, and to your point, Rohit, where a lot of the innovation is happening with algorithms right now is solving these types of very complex problems and trying to do so with in a computationally and financially efficient way. And I think that's where a lot of the innovation is happening, and that's a really exciting space to be in. This is broadly the space that I find myself in kind of heavy ML and AI workloads. I'm not directly hands on with the real implementation details of that, but I'm seeing a lot of this innovation happening in real time, and it's a good point time to bring up that. Uh, no Fluff Just Stuff has a number of these sort of daily live hands-on workshops diving into a number of topics. The ones that are that are standing out to me a little bit are we've got a lot of ML and AI stuff. If you really want to get up to the cutting edge, this particular one is a deep dive. It's an all-day hands-on workshop, and all of these virtual workshops, they're an opportunity for us to stay engaged, stay informed, continue growing, even though we're not able to get together physically in conferences right now. Of course, if you enjoy Rohit's passionate presentation and teaching style, I know coming right up, I think next week, you've got an AWS certified solution architect, and there's a whole lot more in here, but you can see these on nofluffjuststuff.com, as well as all of our past workshops and webinars as well. And right now, No Fluff is doing a pretty good deal. We've got access to the virtual workshop subscription. So it's an all you can eat. You can share this with your team, and you've got a virtual tour stop. We've got another virtual tour stop coming up in March, and of course, you've got some access to our library of really incredible content at ArtConf, where Rohit, I know you were, and I was, I think, as well, at least a little bit, and UberConf, where we both spoke as well.
Oh, yeah.
So, I mean, some really great opportunities to check out. Very limited time on all of these. So if you want to keep learning, if you want to dive deeper, check out nofluffjuststuff.com. But we are out of time. So I'm going to bring it back here. We don't need that. And I want to thank Rohit for your time and your expertise. And actually, I really enjoyed this topic. So personally, I want to thank you as well. And of course, thank you for everybody for taking the time to join us today on the webinar. I look forward to seeing you at another one of these soon. And in due course, when it makes sense to do so, I look forward to seeing you out on the road.
Awesome. See you guys.